Welcome to another nowRail model railway control how-to video, and today we're going to be looking at how to build a system monitor. As part of the how-to series, I've been trying to explain how to use some of the different functions on the custom functions tab in nowRail. So I thought I'd use quite a lot of those functions in this video today, and we're going to look at how to monitor the different transmissions through nowRail. So let's take a look at the workbench. Now, to say that the workbench is a bit crowded is an understatement. I've actually had to bring in an extra USB power supply because my current hub couldn't even power this lot. So let's have a look at what we've got. I've got an touchscreen turnout controller here. And as you can see, as I set the different track directions, I'm actually seeing we've got an accessory command here to move to 2008, direction 1. And I've then got a reading here that's telling me that is the panel response. Hang on, that's the system clock updating, so it's gone 10 seconds past. We can still see that panel accessory command here, and that was saying that the command has moved to that direction, update your panel. Now obviously I've got my touchscreen controller here. If I press some of the functions here, I'm currently on loco 103, so that we can see loco 103 function 7 has been set to 1. If I unclick that, we can see that that then changes to 0. Again, if I change the speed, we can now see that loco 103 has got a speed of 23, then 24, and a direction of 1. If I then decrease the speed and then move into the reverse direction, you can see that I've now got a direction of 0. So this is monitoring the functions for locos, speed for locos, turnout control, panel commands, and the system clock. So let's have a look at how this is built. So I'm going to start off just looking at the IDE here, and you can see the clock slowly moving up, increasing the time. Now if I move my controller and put some speed controls in, you can see those come through. There's some functions coming through, and these are some points being moved. Let's just stop the movement there for a second, and we'll have a look at all of those commands. So we can see nowRail has a diagnostic system built into it. This is great when you're working on, if you like, the workbench, but not so great when you're out on the layout. So if I'm out in the garage, I really don't want to be dragging down a laptop if I have a problem. So what I decided to do was build a system monitor so that I could monitor all the commands that are being sent over nowRail, and that's what today's project is about. So as always, the resources and the code for today's lesson are over on the Digital Town site. So if you just click on the nowRail link below the video, and that will take you over to the following page. So once you get over to the nowRail page, just scroll down and click on this link here, and that will take you to the latest how-to video. Now the circuit diagram here, let's just get the larger version up. It's very simple circuit. You've got your ESP32 and the I2C backpack screen. Now if we just go back to the workbench, this is the I2C backpack version of the 1602A screen. Now the advantage of these is you can just use the I2C library, and that means that you only need 4 connections: SCL, SDA, VCC, and ground. That makes it a lot easier, because otherwise you've got to use all of these different pins and you will quickly run out of pins on your ESP32. Now, the other issue with these screens is that they are a 5-volt screen. Now, there is a way to sort of butcher them so that you can run them off 3.3 volts with just 5 volts to power the actual screen itself. But I find it much easier just to put a level shifter in the way, and that will then, if you like, make sure I've got 5-volt signals to the screen and 3.3 volt to the ESP32. Be aware, if you send 5 volts to your ESP32 pins, your ESP32 is going to have a bad day. So make sure you have some kind of level shifter in there. Now, to save time on today's lesson, I'm not going to go into the basics of connecting the screen. If you click on this link here, it will take you over to this video that I did. This is about how to use the I2C screen with the ESP32. It's a full video just on that subject. So if you've never used one of these screens, it would be worth checking out the video first, because we're going to start with the 5th sketch of this video just to get us started. So loading up the IDE. The first thing to notice about the sketch is the number of warnings to make sure that you do use a level shifter, otherwise you will burn that board. All that the screen requires to run is the wire.h and the liquid crystal underscore I2C library. You then create your object. Now, most of these screens by default come with a value of 27. The reason I've got 26 in here is that on the back of that backpack unit, you can solder across some tabs to change the addresses of the screens, and the particular screen I'm using has had the address changed. So my address is 26, but your default version is going to be 27. The rest of this sketch is realistically about just turning on the screen, turning on the backlight, and then it's showing how to position the cursor, and it then basically prints out a string that goes through a string padding function. Now, the results, if I just go over to the webcam, as you can see, all it's doing is running a counter in decimal, hex, and binary, but it's just showing that the screen is working correctly and that I'm getting the string padding correctly. That's going to be important later on in this project, but it's worth running that sketch before you start trying to connect it to nowRail, just to make sure that you've got your screen connections right. Otherwise, when you try to add a new component and you're not sure if the component's working, is it nowRail that's the problem, or is it the component? So I'd just say, you know, get the screen running on its own without nowRail before you then connect it into the nowRail system. So this is a version of nowRail. This is 1.3.3, and the first thing that we need to do, if you remember the last sketch, it used the wire library and the liquid crystal library. Now, the wire library is set in the nowRail underscore user underscore setup H and is at the top. Just uncomment that and it will immediately include the wire library in the project. Going back then to the main screen, main tab, just add in your liquid crystal library. Now, one thing to be aware of, when you upload your sketch to an ESP32, you will get a warning that says that it's not a valid screen. I'll just, where are we? If I can just scroll through here, let's find that warning. There it is. That's the warning. Library liquid crystal I2C claims to run on AVR architecture and may be incompatible with your current board. Don't panic, it works fine, but when the library was last updated, the liquid crystal, the ESP32 was only just coming out. It was a brand new board. So this library was written, if you like, before the ESP32 became a mainstream board, but it works fine. I've not had any problems at all. So once you've included the library, set up your screen. Now, as I've said, I am using address 26. The default is here, which is address 27. I've then created two string variables. They are both 16 characters long. One is going to be for the text that is put on the top line, line 0. The other obviously is the text that's going on line 1. Now, if you're fortunate enough to have a 4-line display, obviously you can add some extra lines in. Now, coming down to the setup, we're going to start the LCD screen system, turn on the backlight, set the cursor top left and print out line 0. Set the cursor on the left-hand side of the bottom line, and we're going to LCD print line 1. Now, once that's done, we now know that nowRail is running and our screen is working at the same time. So let's get on with starting the project. So once that test has been done, if you scroll down past the main loop, you will see two functions. Now, the string pad function is it's just been copied straight out of version 5 of the LCD lesson that I did, that other resource. The other function that I've got here is just sending information to the screen. Now, what it does is, as before, sets the cursor top left, sends the string line 1 to that. Now notice it's using the string padding function. It's putting blanks in if the text line isn't 16 characters long. Once it's altered the line to the correct length, the reason for doing that is if you don't do that and you've had a line that's longer than the line you're putting in, you see remnants of the old line. So once it's done that, it's printing the value up, then it's moving the cursor again to the bottom line, and it's printing to the screen the text for line 1. Then you'll notice that I've got line 1 equals line 0. So what it's now doing is it's storing the string that was in line 0 in line 1, so that next time a string is passed across and this function is called, the new line will be printed on the top line and the old line will be moved down to the next line. Now, obviously, if you are fortunate to have that 4-line display, you can repeat this another 2 times so that you can see a better history of what is coming through. So now we're going to go over to the customFunctions.ino tab and look at some of the functions that we can use to pass data to our screen. Now, the first function that we're going to be looking at is this one, nowAcComRec. And this is how nowRail gives you the ability to see when an accessory command has been, if you like, transmitted into the system. And I can just serial print out those commands as they come through. If I just reach over and touch the controller, we can see there that some commands are now coming through. That should do 2 commands. That'll be 1 command. Now, if you look at the system here, you can see the nowRail diagnostic lines, but you can also see this line here, accessory command for ESP-NOW 2007 direction 1. And this is this information that is being serial printed from this function. Now, normally you would have this sort of commented out, you just don't need this information, but this function, every time an accessory command is sent over the system, this function is activated. So if you ever want to find out what's going on the system, or if you want to process a command in a specific way that nowRail doesn't have a built-in system for, this is where you would trigger that command. So that's what we're now going to do. And all I'm going to do is uncomment these 2 lines. And the line's quite simple. Line 0 is creating a string, and it's going accessory, and then a string of the accessory number, direction, and the accessory instruction, and then it's just going to call send to display. So if I now quickly upload that, now when I reach over and touch the control panel, you can see that not only does the command appear in the serial monitor, but you can see that the command is now appearing. So now we are able to track any command that is being broadcast over the network. So as you can see, that was pretty painless. So now let's move down to the next function, and this is a now panel update. Now the way nowRail works is it sends out that accessory command that we have just seen, and you can't quite see it. Crushed underneath here is an ESP32, which is representing the left board of my layout. So this is, if you like, my test bench. So the command is generated from the touch screen. It's sent out over nowRail. This ESP32, which would be on the layout, then receives that instruction and obviously moves my turnout appropriately. But then it does two things. Firstly, as soon as it receives the command, it sends an instruction back to say, I've got it, so it doesn't keep repeating the command. But the next thing it does is, once it's processed that command, it sends what's called a panel update. The panel update is being received by this controller here. And the reason I use the panel update is, if I pressed on that command and immediately lit the neopixel within this board, I would assume that that command has gone to this unit. But if this unit isn't working, my panel will still light as if the turnout has moved. So the way nowRail works is you send the command over, and then when you receive the panel update back, that is when I update the neopixel. So actually on the neopixel controller there, I actually use the panel updates to set the values of the neopixels on my control panel. And you can see here there's some example code on just setting some LEDs. But the same sort of function can be used obviously to track those panel commands that are being received. So all I've done here is I have created this next line. So I've called it P, then a space AC, so that I know that it's the panel response. And once again, you get an accessory number and the accessory instruction. Now, this is quite a useful little feature to have on a monitor, because you may be sending out your commands, and so you sort of think everything should be working. But obviously, if the receiving board isn't getting those commands, one of the things you can check is you won't get a panel response. So you can, if you like, you can see the command being sent, but then we have to wait for that response to know that it was sent and received. So now when I send an accessory command, I can see the accessory command was sent. So that would have been line 1. It immediately gets bumped down to line 2 because this unit here has received the accessory command and has now responded with a panel update. So this unit, although it looks instantaneous, it sent the command. It doesn't actually change the neopixel until the panel response is received. But as you can see now, we're now getting the various panel responses. Now, if I click this center button here, it will send 2 accessory commands. So it's sent to 2007 and 2008. And then you'll notice I then get 2 responses in a row. Now, the next item we're going to look at is the now time events function. Now, what I've done just off the edge of the camera, there is this ESP32 right over here. This is my DCC-EX controller on my layout, and that is my layout's master clock. So I've plugged that in, and as you can see, I am getting the diagnostics giving me the time update. It's always a pretty useful function, the time update, because it's happening every second. It's very quick to check when you've added a new board if it's actually receiving information. However, let's just create a line of code. So I'm now going to create a line that's going to start off with SP. SP is going to be the clock speed, because we can change the clock speed within nowRail to whatever speed you wish. We've then got the hour, the minute, the second, and the clock day. So within nowRail, you've got not just the time, but you also have the days of the week. So it's a 7-day clock system. So I'm just going to upload this code now. Now, as soon as that code is updated, you can see that the SP, if you like, the system clock speed is 1. As you can see, the time moving, and we are on day 0. Now, if I bring in my nowRail controller just over here, if I go into settings and clock speed, he says you can always do it. There we go. Increasing the clock speed. I've set that now to 10. As you can see now, the clock is moving much faster, and it's giving you the actual clock speed is now set to 10. Now, I've set the clock speed back to normal speed, but I just want to show you a quick problem with this. If I now click on this button here, press some buttons, as you can see, as soon as I press them, within 1 second, the clock has now overwritten any information that I had from a diagnostics point of view. So although it's great that the clock is working on the diagnostic system, the fact that it is overwriting any other information is going to be a real pain. Now, to get around this in the code, all I've done is created a little if statement. Let's just uncomment that. And the if statement is basically saying only print the time when it is 10 seconds past the minute. So this is only going to print out the time now once a minute, rather than the constant once a second output that will drive me crazy. It's enough from a diagnostic point of view to check that the clock is working without it completely overwriting all the other information. So I've now set a command, and you can see the accessory and the panel command. Now, according to the diagnostics, we're now coming up to 6, 7, 8, 9, 10, and there we see at 10 seconds past the minute, we just see the clock update. But if I continue to press the other sort of commands, I'm getting the clock update, but it's not enough now to overwhelm the other readouts. So now we have the clock sorted, we're now going to go down to loco functions. So I've brought in my controller so that we can see this work. And once again, every time a function update is sent from a controller, this particular function will be called, and you can do all sorts of things from it. In fact, the nowRail controller, I think, is using this function to help update the screen. So what I'm going to do now is L is going to be the loco address, F is going to be the function number, and then the state of that function is going to be printed out. So the code is uploaded, and now as I touch the function buttons, you can see loco 103 function 7 has been set off. I can now do the same for function 3. Let's turn function 3 back on, and you can see that is now working very nicely. So we can now see any function updates. Now, once that's done, we can move down to loco speed, and I'm going to be very quick with this because I want to show you a sketch that someone else has sent me. So let's just quickly get this updated. So now we can see that not only can we do the functions, but if I now do a speed change, we can see the various speeds coming through. I'm in reverse at the moment. Direction is 0. As I move to the forwards, the direction goes to 1. Now at this point, I want to bring in a video that was sent me by Felipe, and this shows how he has used the Now Loco speed update, and he's created himself a loco speedometer using nowRail. Take a look at this. So what he's done is, using a sort of a map function, he has been able to map the loco speed updates and create himself a very nice pair of speedometers. One obviously a digital display, the other looking like an old-fashioned analog dial. Now the thing that was interesting about that analog dial is if we go back to the now time events, it would be possible to update a digital version of a clock around your layout using that same sort of display. That is an ESP32, and on the back of it, it has actually a round LCD display. So ideal for sort of a mini speedometer or for clocks on your layout. And of course, with the nowRail system, it will keep all your clocks running to the same time. It always fascinates me what other people do with the system. Now, just to finish, I'm going to go down through a number of functions down to the now power command and just uncomment this one. The now power command is when a command is sent to turn on or off DCC-EX if you've got it connected to the system. It's also used within nowRail for emergency stops, because the way that the NCE system works is a little bit weird. So yeah, it's used for that. But let's just get that one uploaded and you can see that one working. So now if I go to my controller, I turn DCC-EX on and off using this one. You can see I'm getting a value of 3 and 4. You'll notice a very slight flicker when I do this, and that is because power commands, when they are sent out 5 times. So it's actually receiving the command 5 times. The reason for that is, in an emergency stop situation, I wanted to be able to make sure that everything was shut down with no delay whatsoever. And if a transmission was missed for any reason, I still wanted the power to be shut down. So that's the reason that you see that. As you can see, we're now 10 seconds past, but now we've got our functions working. If I go to higher functions, you can see that they will come through in just the same way. We've got our speed commands, and we've got our accessory commands and our panel update. Now, going forwards, as this seems to work really well, I'm thinking of adding one of these screens into my DCC-EX base station so that I can see the nowRail commands being sent over at any time throughout the system, just so I can use it as a monitor, which is exactly what it's meant for. But one of the things I hope that you can get out of this is not just the monitor, but the idea that these different custom functions can be used to drive all sorts of events throughout your layout, And as you've seen with Felipe's video, speedometers and all sorts of things that, I haven't even dreamed of, they can be done using these custom functions. So that's it for today. I hope that's proved useful in showing how to use the custom functions. Thanks again to Felipe for sending over that brilliant video of that speedometer. I was just looking at it and thinking that would make a really nice clock for one of the buildings that I'm working on, but it just shows just how custom functions can be used. So thanks again for watching, and if it has been useful for you, please click the like and subscribe, because it really does help the channel. Thanks again for watching, and I'll see you in the next video. Bye for now.